Hello dear student, I am Monul Islam. Today in this video we are going to discuss an important topic from analysis, and this topic name is countable uncountable. Countable and uncountable. Okay, this is question. This is topic from analysis. Okay, and it is this topic what it is in CSIRNET exam is very important. Okay, it is very important topic for CSIRNET exam. In this if you observe the previous years, then you will always find then there is at least two questions. One is part B and one is part C. Okay, this 3 mark and this is 4.75 mark. Okay, so you can expect at least 7.75 mark from this topic. Okay, sometimes more question come. Okay, also it is very important for CSIRNET exam. Also CSIRNET exam is very important. Also it is equally important for CSIRNET GATE, CSIRNET GATE, TIFR, NVHM. Those who are want to give this exam, this is also very important topic. Okay, so this topic has made more weightage in every competitive exam. So we have to understand this topic very carefully. Okay, and we have to not only we focus only theory, we focus on problem solving. Okay, if you solve problem more, you will learn more. Okay, so let's start. First of all, let me introduce a definition. Okay, it is equivalent set. Equivalent set. This video is divided by two parts. Okay, first I tell you the two concept regarding to solve question. Okay, after that I solve CSIRNET question, previous year question. It is 5 question. Okay, so equivalent set, a set. Suppose you have two set A and B, then we say A and B are equivalent, and we denote this to equal and opposite. We say A and B are equivalent. Okay, A and B are equivalent. If there is a map, F from A to B, that is bijective. So to set A and B as set to equivalent, if there is a map between two set, there is bijective. Bijective means one and on two. Okay, injective and on injective and surjective map. Okay. Moreover, if both A, B are finite set, if both A, B are finite set, then if this happen, A equivalent to B, okay, then you can write from here coordinate of A equal to coordinate of B. Okay, in case of finite set, you can say coordinate of A equal to coordinate of B. Coordinate means number of element A equal to number of element B. But in case of infinite set, you cannot say this. Okay, you can, in case of infinite set, you cannot say this. Now I am giving an example so that you understand very easily. Let A be a mapping from set to real number to interval minus pi by 2 to pi by 2 by fx equal to this very important mapping 10 inverse x is belongs to R. Okay, we all know what we know. We know that mod of 10 inverse x, magnitude of 10 inverse x is always less than pi by 2. Okay, for all x belongs to real number, or you can say minus pi by 2 less than 10 inverse x less than pi by 2 for all x belongs to 10 inverse x fx. So fx is lies between this interval minus pi by 2 open pi by 2. Okay, so from here you can say the range of f will be open minus pi by 2 1 pi by 2. This is a codomain. Okay, so range equal to codomain for the function f. So you can say from here f is onto map means surjective. So f is surjective. Now I need f is injective. Okay, so that I can say f is bijective. Now clearly f is injective. For injective to show injectiveness, you have to show f is equal to fi implies x equal to y. So I am assuming f is equal to fi for some xy real number. For some xy belongs to R, I am assuming f is equal to fi. So this gives tan inverse x equal to tan inverse y. This gives x equal to y. So it is injective also. So this map is injective and surjective. This map bijective. So you can say the set R and this interval are equivalent. Okay, according to my above definition, you can say this set are equivalent, right? But see, it is a power subset of R. Okay, so in case of inverse set, a power subset of this set can be equivalent to this set. Okay, but in case of finite set, it may not be possible. Okay, in case of finite set, a power subset never be equivalent to this set. But in case of infinite set, it is infinite set, so it can be possible a power subset to be equivalent to a set. Okay, this is a question from, I think this question came in GET. Some year GET. There is a statement that can an infinite set be power subset of it to its subset? Can infinite set can be equivalent to its power subset? So this example can you take? Which is infinite set which is equivalent to its power subset. Okay. But in case of finite set, it is not happen, because suppose if it is a finite set A, it is n element and it is a proper subset B. Okay, proper subset B, and B has suppose less than n element, suppose n minus 1, then A and B never equivalent. Okay, because if it equivalent, suppose it is equivalent. But in case of finite set, you know A and B equivalent, it means they both have same cardinality. Cardinality will be n and cardinality will number n minus 1. So this gives 0 equal to 1. This is one direction. Okay, this never happen. So true finite set never be equivalent. Now we are going to consider countability. What is countable? Then after we are going to consider uncountable. So countable. What is countable set? Suppose A be a set and is subset of real number. Okay, A is subset of real number. Then it is said to be countable. I am writing in short form. CTBL. Countable if either it is finite, if it is finite set, or it is equivalent to set of natural number. Okay, equivalent means there is a bijective map f from natural number to this set. If f is bijective, then we know inverse is also bijective, right? So there is a bijective map from natural number to n also. There is a bijective from A to n also. So A set is countable if it is either finite or it is equal to set of natural number, means there is a bijective mapping from A to n. Okay, can you give me some example of countable set? I am writing an example. Okay, Z set of natural number is countable. Why? Because there is a bijective mapping from Z to n. See, you can write, if you choose the mapping like this, f from n to Z, f from set of natural number n to Z by fx equal to x by 2 if x is even, because x is a natural number, right? X is a natural number, then fx will be integer. Okay, this is a natural number, so x may be odd or even, odd natural number, even natural number. If x is odd, so I am mapping it x by 2. If x is even, then I am mapping x by 2. But if x is odd, then I am mapping it 1 minus x by 2. Okay, clearly this map is 1 also and all to on 2 also. Okay, this is a bijective map. So I can say n natural number set is there is bijection between natural number to Z. So I can say this set are equivalent. Okay, this set are equivalent. This set are equivalent, and since natural number is countable, so Z is countable. Okay, so Z is a countable set. Similarly, you can say that q, set of natural q, set of natural number, it is a countable set. Okay, you can write like this: q can be in q plus, q minus, union 0. And there is also a result. Okay, if a set is suppose a set is countable, I'm not going to prove this, I'm just stating the result. If suppose a is countable set, CTBL, okay, b is countable, and the union is also countable, and the union a union b is countable. Okay, moreover there is also a result: intersection of countable set countable, because intersection is nothing but subset. Okay, suppose a is countable set, b is countable set, then intersection a intersection b is always subset of a. Okay, it is subset of countable set, so it is trivially countable. So intersection is also countable. Okay, intersection is countable for two set. Similarly, for arbitrary, there is also a theorem. Okay, there is also a theorem. I am writing the theorem. Okay, not going to prove, because I have to focus on question. Suppose ai are countable, each ai are countable. Suppose ai for I belongs to say natural number is countable. Okay, sorry, I'm saying that suppose ai, each ai is a countable set. ai means for I is 1 2 3 so on, right? ai are countable set. It means a1 a2 a3 a4 a5 6 all are countable. Then you can say their union, countable union, I equal to 1 to infinity ai. Okay, or you can say like this: n equal to 1 to infinity an. Okay, this is countable union. Countable union, countable set is countable. This is also countable. Okay, this is also a theorem. You can search in any book of real analysis, you get easily of this book. Okay, I'm not going to prove this. Also, this q can represent q plus q minus 0, where q plus being the set of positive natural number. Okay, p by q, p q is natural number, right? Q minus be the set of negative natural number, p q is natural number. Okay, if both sets are countable, this is countable, this set countable, you can find a mapping from natural number to this set. So natural number, you can find a mapping from n cross n to this set. Okay, what is the mapping? Same writing. Also note that we know n is countable, right? Because there is always a budget mapping from natural number to natural number. This mapping is identity mapping. You can choose the mapping if n equal to n. Identity mapping. This mapping is budgetive, so natural number set is equal to set natural number, so natural is countable. Okay, you can also say that this find Cartesian product n cross n, or say n times product. Okay, n is also countable. Okay, find Cartesian product of countable set is countable, right? And moreover, we denote say set of natural number cardinality n to be r if not. Okay, and so the cardinality of n cross n will be cardinality of r if not, and this r if not, and this is r if not, this n times, right? This n times, so this become r if not power n, so this one r if not, so this is also countable. So finite Cartesian product of countable set is countable, but if it is infinite then it is not countable. Okay, if it is infinite then you cannot say it is countable, because if it is infinite or countable product, then it gives n cross n so on. So current of it gives r if not, and this product is r if not times, so this gives r if not power r if not. Okay, and we have a result on cardinality. If suppose alpha be cardinality of a set and beta be cardinality of another set, then alpha to beta will be equal to 2 to beta if alpha is equal to beta. Okay, here say alpha r if not equal to r if not, so equal to hold, so you can say it is 2 power r if not. Okay, 2 power r if not equal to continuum. Continuum is uncountable. Okay, you know this after sometimes. So it is uncountable set. So I am saying the infinite Cartesian product of n is uncountable. Okay, or countable infinite product of n is uncountable. Okay, but finite Cartesian product is countable. Now, if you know this, So I'm saying this why q plus is countable. Okay, this set q plus is and q minus is countable. Okay, because there is a biased mapping. You can choose a mapping like this: f1 from n cross n to q plus by f of p comma q by p by. This is a biased mapping. Okay, so biased mapping means this is a not biased. This is a on to map. Okay, this is on to map. We all know if from a to b is a to b is on to map, then current to this will be current get equal to current to this always. So you can say current to n cross n will be greater than equal to current of q plus. Okay, but it's a countable set, just prove. So current will be less than this, so it will go into countable. Similarly, q minus is also countable because you just choose a mapping n goes to q minus by f of pq equal to minus p by q. F of pq equal to minus, if you choose f of pq equal to minus p by q, then you get this set is count, you get this maybe onto. Okay, this may be onto map, and since if you have a mapping f from a to b, this onto, then current domain will be greater than current domain. Okay, so in this case n cross n current will be greater than q minus current, but it is countable. This current will alif not, since this current will less than alif not, you can say this set is going to countable. Okay, so q plus countable, q minus countable, and this union of 0, nothing but union of 0. So this set countable, this set countable, and this is countable also. So countable concept countable, so q is countable. Okay, so you can say q is countable. So okay, also subset of countable set is countable. Okay, you can say this set a equal to open 0 and intersection q. This is nothing but subset of q, 0 and decimal. So it's the subset of countable set, so it is also countable. Countable, it is countable. Countable, right? Now can you tell me, now we are going to the concept of uncountable set. Uncountable, a set is uncountable, it is not countable. When you say a set is uncountable, it is not countable. Okay, then we say the set is uncountable. Can you give me some example of uncountable set? Can you give me some example of uncountable set? See, this is the result. Okay, I am writing this result for any set a. For any set a, cardinality of power set means number of element power set of a equal to 2 power cardinality of a. Okay, for any set a, for any set a, cardinality of pa power set of a equal to 2 power number of element a. What is power set of a? Power number set of subset of a. The set is contains the set b to subset of a. Okay, so you can say from this result you can find a uncountable set. If you choose a equal to n, if you choose a equal to set of natural number, then what happen? Current of this will be 2 power current of natural number. Okay, means 2 power alif naught. Current in current of n is alif naught. 2 power alif naught means c continuum. Okay, so power set of n is uncountable. And if it set is countable, then its cardinality will be less equal to alif naught. If I am saying that if it set is countable, then its cardinality will be always less equal to alif naught. Okay, if it set is uncountable, if it set is uncountable, then its cardinality get equal to c continuum. Okay, but there does not any set whose cardinality is between alif naught and c. Okay, there does not any set whose cardinality less than cardinality between cardinality which alif naught and c. Okay, in between. There doesn't be any set. Okay, if it's countable, then cardinality will be less equal to alif naught. If it's uncountable, then cardinality will be in continuum. Continuum is 2 to the power alif naught. Continuum equal to 2 to the power alif naught. Okay. Now, also there is a famous example of uncountable set R. You can say set of real number R. Set of real number R is uncountable. Okay. In every book of real analysis, you get this proof. That set of real number uncountable. I am not going to prove this because it is not needed. Okay. I'm just telling you what is the proof method. Every book is done that first 0 1 is uncountable. First it is you have to prove this 0 1 is uncountable. Okay, and 0 1 subset R, since it is uncountable, it contains this uncountable is so R is uncountable. Also you can, I just told you, then you also use the concept. The example, if is equal to 10 inverse x. From this example you can say R is equivalent to in the interval, equivalent to in the interval this, okay, and this interval is uncountable, so since it's uncountable, so R is uncountable. Okay, now without wasting time, I am going to do some CSIRNET question, okay, with the concept that we have learned now. So this question, it says let A be any set and P is into power set of A, then which of the following are true? Okay. This is a question from June 2016. It's saying P equal to 5 for some A, power set A equal to 5 for some A. Okay. See, so if A equal to 5 means A is no, if A equal to 5, it's empty set. A is empty set. If A be empty set, then what's the current of power set of A? Current of power set for any set we know current of power set will be 2 by A, okay, but A has no element, so current will be 0, 2 by 0 is 1. See, power set equal to 1, power set current of power set equal to 1, this means power set A never 5. Okay, so if A equal to 5, then power set is never 5, not equal to 5. Okay, but if A equal to some if A equal to some element, then power set is also not equal to 5. Okay, it's trivial case. If I am considering A equal to 5, then also power set current is 1. Okay, just thought. So if A equal to some element, suppose A has 2 element, okay, then its current will be 2 part 2, okay, 4. So it's never 0. Okay, if power set equal to 5, then for some A, then the current of power set will be 0. Okay, but not possible. Power set current is never 0. So it is incorrect. So option 1 is incorrect. Now it said power set equal finite for some A. Okay, obviously if you choose a finite set, suppose it is x n element, x1, x2, xn. Okay, finite set. So you can say current of A hn. Then from here you can say current of power set of A will be 2 to the power current of A. This is the result we know. Okay, so it will be 2 to the power n. So it's a finite set, right? The power set current 2 to the power n. So this means this set is finite. So if you choose A this, then you get power set is finite. So power set is finite for some set A. So option 2 is correct. Okay. Now it says power set A is uncountable for some A. This example work, just I written. Okay. If I choose this example also work. Option 2 and 4 and 3, same example work. If you choose A equal, just write, I have written this. x1, x2, xn, it contains n element. A set contains n element. And then you can say current of A is n. Then for any set A, we know power set of current will be equal to 2 power current of A. Okay, and this is 2 power n. Okay, since finite set, we know every finite set is countable. Okay, since A is finite set, so it is countable. The power set is contains 2 power n element, so it is finite. We all know every finite set is countable. Okay, so it is countable. So if we choose this A, then we get power set is countable. Okay, so option 3 is also right. Now option 4, power set is uncountable for some A. Look, if you choose A equal to set of natural number, okay, then what is the power set? You know, current of power set A will be 2 power current of A. Okay, so it will be 2 power natural number current A. This is 2 power alif naught to the argument is C, quantum. Okay, so quantum is uncountable, so this set is uncountable. Okay, so power set is uncountable for some A. So option is correct. So in this question, correct option are 2, 3, 4. So in this question, correct option are 2, 3, 4. Hope you understand this question. Okay, if you understand the question, I am doing one more question. For the question, I am doing one more question. This question from December 2013. Okay, I am going to consider this question. This is the set A B belongs to R2 such that A is equal to B. It says which of the following subsets are uncountable. Okay, there are 4 options given. In question came December 2013, part C question. So first set is this, A belongs to R2 such that L is equal to B. Okay, I'm writing like this, xy belongs to R2 such that x is equal to y. Okay, this line is x equal to y. Okay, 1.0, x is equal to y means the upper part. Okay, so this set saying the you have to consider the point that are lies the region this of the line. How many point in the other how many point are in the region of the line? The uncountable point. So this is uncountable. Okay, so option 1 is correct. So this set is uncountable. Now consider set 2. A belongs to R2 such that A plus B belongs to rational. A belongs to R2 such that A plus B belongs to rational. Okay, you can this A plus B belongs to R2, A plus B equal to R. You can like this, R equal to rational. Okay, A plus 1. If you choose the rational number is 0, then you get x plus equal to 0. X plus 0 means x plus equal to 0 means I'm writing A as x, B as y. So x y belongs to R2. This set becomes x plus 0 means y equal to minus x. So you get this line. Okay, if you choose 1 x plus, if you choose r equal to 1, so you get this line passing by 1.0 0 1. If you 2, then you get 2, passing line passing through 2.0 0 1 2 minus 1, then this passing line minus 0 minus 1. If you choose 3, your line passing through 3.0 0 1 3. If you choose minus 3, you will get line passing through minus 3.0 3.3. Similarly you get uncountable line. Okay, uncountable line. So this set is also uncountable. This set is also uncountable. Also you can thought like this, A belongs to rational R2, A plus B equal to R is rational, so you can like R minus A. Okay, so put in place of B equal to R minus A, and you can say this set contain this set. If you choose R equal to 0, then okay, because if the R is rational, so if you I can choose R equal to 0, then this set obviously contain this set. Okay, but this set is uncountable. The uncountable is also way. So this set is uncountable. Okay, now you can do option 3rd. So it's correct. A belongs to R2. Is set this set. A belongs to R2, so that AB belongs to Z. This set is also uncountable. If you choose AB equal to K, or K is an integer. Okay, and then if you choose K equal to 1, then this gives rectangular hyperbola. Or x equal to C, just K square. So x equal to C square, this gives rectangular hyperbola. So how many points in this line? How many points is rectangular hyperbola? Uncountable. There are uncountable point on rectangular hyperbola. Okay, so this is uncountable. But you can also thought like this. Choose A equal to K, so you get B equal to K by A. Okay, so you can write like this, B equal to K by A belongs to R2, so that A belongs to R. A is non-zero. Okay, so there are uncountable choice of A in this case, so this is uncountable. There are uncountable choice of A. Okay, so this is uncountable. Now, so option 3 is correct. Option 4, this A belongs to AB belongs to this set. AB belongs to R2, so that A belongs to rational. Okay, so you can write the set like this, Q cross Q. Now it is find curtain about countable set. Is countable. Q is countable. We know the countable. Find percent part of countable set is countable, so it is countable. Okay, so it is countable. So it is not countable, uncountable. So in this question card is 1 2 3. In question card is 1 2 3, right? I'm giving one more question. Suppose you have set A, okay, and set B is 1 to m element. Okay, this 1 to n element. This set is m element. This set is n element. Okay, then how you can say how many functions between these two set A and B, between A and B, how many functions can be drawn? Okay, see, one can map either 1 2 or n. Okay, so one has n choice, right? Either 1 2 n. So 2 can map 1 either 1 2 or n. So 2h n choice. Similarly, m can map as 1 to n, so this is also n choice. How many times this? M times. So total will be n to n. Okay, so n means coordinate of B or coordinate A. So you can say total number function from the set A containing m element to a set containing n element will be coordinate B to the coordinate A. Coordinate B to the coordinate of A. This is the total number function. Total number function. Can you say total number of function m plus 1 function? How many total number of function from these two set containing m element n element? This will be the formula npm. Okay, this is called n factorial by n minus 1 the factorial. N factorial upon n minus 1 factorial. And see this factorial part n minus 1 there is factorial in n minus 1. Okay, so obviously n minus 1 will be greater than equal to 0. Okay, because factorial negative factorial never defined. Okay, so n always greater than equal to m. So you can say coordinate of B coordinate of greater than equal to A in case of function 1 on, if it's 1 on. Okay, now using this concept there is a question in CSIRNET. Okay, so I am solving this question. This question from June 2013. Okay, S is given S at A is coordinate 3 element 1 to 3 is 5 element. Okay, in this question A has 3 coordinate 3 because A 3 element, B has 1 to 5 1 2 3 4 5, so B has 5 element. Question asking total function from A to B. Can you say total function from A to B? Total function will be coordinate B per coordinate A, right? Coordinate B is 5, coordinate B A, so 5 to 125. Total 1 function. So 1 to 5 2 4 3. Option 1 is correct. Total function from A to B will be 1 to 5. Okay, not 2 or 3. So option 2 is incorrect. Option 1 is correct. Now asking total 1 function from A to B. So 1 is correct, 2 is incorrect. Total one, no, option 3 and 4. It is asking total number 1 function. Now we all know total number of function and there is 1 on. This formula npm. N means coordinate of B and m means coordinate of npm means 5p3. Okay, npm. N is 5 and m is 3, 5p3. So 5 factorial. npm is m factorial by n minus m factorial means 2 factorial. So 5 4 3 2 factorial upon 2 factorial, this is 60. Total number on function will be 60. So option 3 is correct. Not 4 is not correct. Then the question correct option are 1 and 3. Okay. Now we are going to solve one more question of CSIRNET. Using the concept that I have learned that if I have a set, it is not necessary that A will find a set, B will find a set. Okay, A may be A and B may be in a set. Then also the result true. I am just giving the example for find set so that we can understand better. Okay, so I can say total number function from the set A to B. This coordinate will be coordinate B per coordinate of A. Okay, this is the concept. Total number function from set A to set B is nothing but the coordinate of B to the coordinate of A. Okay, this is the concept. We are going to solve a question from CSIRNET. This is question from June 2018 and question asked in part C. Okay, it's saying total number function from the set R to 0 1. Okay, so it asking total number function from R to this set is 0 1. So using the formula, can you tell me what is the coordinate? Coordinate B. B means this is coordinate 2 and coordinate of R. Coordinate R means continuum. Okay, 2 to C, and 2 to C is always greater than C. Okay, 2 to C is always greater than C. So since C is coordinate greater than C means continuum, so it is uncountable. This set is uncountable. Okay, so option 1 is correct. Now the option 2 is a settable function from n to 0 1. Saying option 2 saying total function from n to 0 1. How many functions from n to 0 1? It's coordinate 2, it's coordinate alpha naught, so total function will be 2 to power alpha naught, and we all know 2 to power alpha naught equals C continuum. This is uncountable, so this is uncountable. So option 2 is also right. I'm going to option 4, the settable subset of n. Okay, we've already discussed. Set of subset of n. What is the set of subset n? Subset of a set A will be power set of A. So set of subset of A will be power set of n. Subset of n will be power set of n, and current will be 2 power that set. Natural number 2 power natural current is alpha naught is C. C is uncountable, C is uncountable. So this is uncountable. So this is correct. Now it is asking the settable find subset of n. Now settable find subset of n. Okay. Settable find subset of n. Set of finite subset n. Set of all finite subset of n. Set of all finite subset of n. If name this set A, then this set is equivalent to set this. Set of natural number cross natural number. Find many times. You can say suppose n times. Okay. We all know finite product of countable set is countable. This is countable. This is countable. So their finite product will be countable. In this set is finite alpha naught. Okay. So settable finite subset is countable, but settable infinite subset is uncountable. Okay. Settable finite subset is countable, but settable if it's infinite then it is uncountable. So settable finite is countable, so it is not correct. Okay. So in this question correct answer 1 2 3 1 to 4 1 2 4. This question correct answer 1 2 4. Okay. Now we will to solve question 5. Okay, this question asked in December 2017 from in part C in the 4 potential mark. What is the question? It said for a set X, P is denoted of the settable half set of X and omega X with the settable function from X to 1. Okay, so in this question say Px with the power set of X. Okay, we all know. So current of power set will be any set A, current of power set will be 2 to the power this currency, so its current will be 2 to the power X. Okay, and here given omega X is nothing but settable function. So this is a function that map from X to 0 is given. Okay, so can you tell me what is the currency of omega X? Will be this current 2, this current X, current X. So total function from A to B will be 2 power current of X. See both set current same. Is current 2 by X and this is current is 2 by X. 2 by current of X. Okay, since both the current is same, so you can say current of power set of X will be current of this set X. This is current same, so you can say current of both the current is same. Okay, now we are going to the option. It said X is finite, then power set is finite. Okay, it's saying X is finite and power set is finite. See, if X is finite, suppose X is an element. Okay, then we all know current of power set X will be current of that set. X is an element, then it says 2 by an element. So it is 2 by an element, so it's finite set. Okay, so option is correct. It said if X and Y are finite set, then it's finite set, and there is a one correspondence between Px and Py. Then there is a one correspondence between X and Y. Okay, X and Y are finite set, and there is one correspondence between Px and Py. There is one correspondence between Px Py. So you can say current of Px will be current of Py. Okay, so you can say current of Px will be 2 power X current of X and 2 power Y. And this means current of X will be current of equal to Y. Okay, you can take log 2 both sides. If you take log 2 both sides, then log 1, this is current of X or current of Y. Okay, since current of X current of X, so X and Y are equivalent. Okay, then between order correspondence. So option 2 is correct. Okay, now go option 3. It says there is order correspondence between X and Px. It is not possible by Cantor theorem. We all know Cantor result. Okay, we have all learned in MSc a result that's called Cantor set, Cantor's theorem. This one says there doesn't be any bijection. There doesn't be any onto map F from X to Px. Okay. Okay, or you can say there doesn't be any on map from Px to X. Okay, so there doesn't be any on correspondence between Px and X, because it is if it's on, suppose it is on. suppose this map is 1 on. If it's 1 on, then you can say if A to B is 1 on, then you can say current of A will be less equal to current of B. So current is A is this, B is this. So current A will be less equal to current of B. Okay. Then you can say 2 power current of X will be less equal to current to X, but it's never possible. It is contradiction. Okay. Current 2 power is never equal to current to X. So it's contradiction. So the chance is 100% in PS and X. So option 3 is incorrect. It's saying there is a 1 constant between omega S and PS. Obviously, because I just written that both set of current is equal, right? We observe that current of power set X will be 2 power current of X, and current of omega S will be, I've just written, is 2 power current of X. Both set current is same, right? Because the omega is a function from 0 x to 1, so it is current of 2 power X, and the power set, so current 2 power that set. So this set, both set current equal, so current of power set will be current of this set. Okay. So you can say current of both set current equal, so you can say they are equivalent. So both there is on-to-one correspondence between two to Z. So option 4 is correct. So in this question, correct option are 1, 2, and 4. Okay. So in this question, you can say correct option are 1, 2, 4. So if you any doubt, you can always ask in the comment section. Okay, and please subscribe my channel to get more update. Okay, and I've just started this chapter, and after there are more video come in this topic. Okay, so thank you.